Okay, and we're live now. Cool. So I'm going to ping everyone on Discord, and then we'll wait a bit for people to connect, and we'll start. Let's also start the meeting on Discord. So if you can connect to the room on Discord to start the event. There. All right. So the event is starting now. Can people on Discord hear me? Nope, not yet. Now they should be able to hear me. Hello, everyone on Discord. Okay, so I can see people are logging into Discord. I'm not so sure about YouTube. Let's see. Okay, there are some people on YouTube also. All right, so it's 2:32. Let's wait 2 more minutes and then we can start. Okay, so we have 70 people waiting in the audience. Luca, can you connect to Discord also so that, I mean, you can connect when you talk a bit later on. Okay, so let's start. So welcome everyone. Thank you for joining us for this 13th community call. Today we are going to talk about the roadmap, new versions of StarkNet Alpha, so one of them which is released and deployed today on testnet, and which will come to mainnet a bit later on. And then we'll talk about an upcoming important feature, which will come in version 0.9. And finally, we'll talk a bit about education material and resources for StarkNet, and how we can help onboard more people collectively to build cool stuff on StarkNet. So I'm going to start with 0.8.2. Let me check if I'm sharing the right screen. Yes, I am. Okay, cool. So okay, so I wanted to briefly cover what is included today in version 0.8.2 of Cairo Lang, and which is deployed today to testnet. So it's not a major version, 0.8.2. You already had 0.8.0 and 0.1 that were deployed before. So as you can see for StarkNet, it was mostly about performances. So performances, fixing a bug, and adding some fields into the block info that were retrieved. Something I wanted to underline, however, is the inclusion of Kitchak and the Ethereum signature verification into the Cairo library. So This is basically just taking something that was done in an outside library and including it in the repo so that it's easier to access inside of Cairo and inside of your Starknet smart contract. That way you don't have to clone the file and then import it. But it won't affect the performance of these functions. These are still the same Cairo code. They're still written in Cairo, and so you won't get necessarily performance improvement. It's just that these are the, let's say, canonical libraries for now. In order to get performance improvements for these functions, so for Ketchak or for signature verification, we'll have to convert these in what we call built-ins. So which are, let's call them like optimized functions for Cairo. So they run faster and they will save you a lot of steps in your contract. We don't have a fixed timeline for that. It will come, but for now you can still use these libraries instead of importing things from elsewhere. So that's a minor release we have today. Something I wanted to share with you was this web page, which I'm going to share in Discord and which I'm going to share also. Well, I'm going to share it in Discord. Actually, I'm going to share it now in the community call channels that people have access to it and can read with me. So I'm going to post it in the community calls channel, right? So I see that there are some questions in the community call channel. Just want to underline that you can follow the call either on Discord in audio only, or you can follow it in YouTube. I'm going to share the link also in Discord, and that way you can see the stream. This is for Axel. I think the Lax is Axel, who is trying to see my screen. Okay, so coming in version Alpha 0.9.0 will have a big change in the way contracts are considered in Starknet. So the document really sums it up well, but I wanted to cover live here some of the key aspects of it. So as some of you may know, on Ethereum, there is a very large number of smart contracts that are deployed, which are essentially the same code. They're small variation on ERC20 and ERC721 by OpenZeppelin. And they're just deployed and with some parameters that are changed. Each of them has its own storage. And for each of them, we store the code of the smart contract. But for a lot of them, the code is duplicated and remains the same. So for example, think about the way Uniswap v2 works. Every time you want to deploy a pool of assets, the code for this specific pool is duplicated. So part of it is inside a library, so there is some efficiency there, but to a large extent, we create a new storage for a new pool and we store some code, and this code is duplicated. So the reason why it took us some time to ship the contracts factory in Starknet is that we wanted to get this design right in light of years of experience of looking how Ethereum works. And so we went with this approach where we will separate what we call a contract class and a contract instance. In a nutshell, you can think of the contract class as the code of a smart contract and the contract instance as a triplet which will point to a contract instance, so a specific code, a specific storage, and a specific address, right? And so it's a very simple design, right? You have the code, and then you'll have the instance of this code, right? However, this will imply some immediate change in how you deploy a smart contract, and then there are some larger changes in how you design your smart contract, which we can discuss also later on. So basically today, when you deploy a smart contract, you send the code, it gets an address, it's stored, and you have a new contract. Now, when you declare a smart contract, there will be two actually calls to be made. One of them will be a declare transaction, where you'll create a contract class. So you will basically send to Starknet the code of your contract without deploying it. And then there will be a new deploy smart call, which will work a bit differently than the deploy call you have now, which will basically say, okay, so I want to create a new instance of a smart contract. It is using that specific class for its code. And then at this point, your contract will get assigned an address and some storage. Some impact to this are first that the way delegate call will work will be a bit different. Today, if you use delegate call, basically your smart contract A will send delegate call to smart contract B. In this new paradigm, you won't delegate your call to a smart contract instance. You will delegate it to a smart contract class. So it will change a bit. Instead of specifying the address of the contract you want to delegate to, you will have to specify the hash of the class. So basically, the hash of the class will be the thing we use to index all the smart contract classes that are deployed. And so you'll have to specify where the code you want to execute sits. Alongside, I'm just reading through the documents here. So if you have questions, feel free to ask them or comment. Same thing for proxy contracts. Instead of having an implementation address points to a smart contract instance, it will point to a class hash. So it will point to a repository of code where things will be stored, right? Now, yes, there will be also some changes made to account contracts, because this will allow having a syscall where you can deploy a new smart contract instance from an account contract. This opens the door to paying for fees for deploying new contracts, contract instances from the smart contract, the account smart contract. This will also change the APIs, right, of Starknet. Now you don't have, today you have a single endpoint to, you designate a smart contract as both the code, the storage, its address. And also now we will distinguish between the smart contract instances and the smart contract classes. So the API will reflect that change. Now, this is a first step, and as you know, Starknet is in deployment, so we don't have all the answers, but this will bring quite a lot of change. It will bring the capacity to have factories. So with 0.9, we will be at feature parity with Ethereum. We'll be able to, anything you can do on Ethereum, you'll be able to do on Starknet. However, some questions remain open. The first thing is, how do you pay for deploying a smart contract class? How do you pay for deploying a smart contract instance? How do you price both of these? What is the resources it takes? How much it should be, and things like that. And second question, which remains open, is still the same. Everyone is asking is, how do you seed, in a way, your account contract? It's not how you seed it, but it's, you're a new user, you don't have money on Starknet yet, how do you create an account contract without being able to pay for your deployment? So these are open questions. I think there are some others that are missing, but the first one that comes to mind is, how does this affect the way we write smart contracts for Starknet? Because, and I think this is a very important question for people writing standards such as ERC20, ERC721. Today, it is possible. I mean, if you go on Ethereum, you can take ERC20, ERC721, and then customize them a bit and deploy them. There are some arguments in the constructor you can use to make your contract parameter like to your taste. Here, this logic will be pushed even further because there will probably be a bonus, like not a bonus, but it will be cheaper if you just deploy a new smart contracts instance compared to if you deploy both a smart contract class and a smart contract instance. So making your contract versatile and reusable will be very important. Anyway, so, and this also opens the door to other funny stuff where you can deploy a smart contract class to Starknet without creating an instance. And so your smart contract can be, I mean, your smart contract class is deployed to Starknet, and you can have a contract that delegates code to this smart contract class without this instance being deployed anywhere. So anyway, it's a funny construction. So yeah, I wanted to cover this document. I'm going to check if there are questions. Okay, so apparently people can't hear me anymore on Discord. Too bad. Discord is not always perfect when we do these things. Oh, apparently, yeah. Oh, okay, people can hear me on Discord. Okay, perfect. I need to check if there are questions in YouTube. And so GetBoot is asking, who do we have to thank for this external implementation? I'm guessing you're talking about the Cairo, the Kitchak, and the Ethereum signature Cairo code. I don't know, so I can't give attribution. Sorry, but they were included in by our team. By the way, I think this is also something that eventually will be done for other libraries. Today there's a lot of fragmentation of libraries, and we need to come up with a way so that external libraries that are made by members of the community will be included in the Cairo Lang package globally. All right. So I don't see any questions, so I'm going to move on. So this feature, contract as classes, which will be released in 0.9, is not the only thing that will come in version 0.9. There are some other things in the pipeline. Most notably, there will be some changes around fees, so we'll keep you up to date with that. So it's not the only one, but it's an interesting one. It's the one I know has been implemented and will be shipped. So I wanted to present to you that. And now I want to switch the second part of the community call. Let's talk a bit about Starknet education and Cairo education. So as you know, there are 3 of us now in the Starknet EDU team. There is Ben, who is on the Colorado time zone. There's Lucas and I, who are in the European time zone. Basically, what we do is try to come up with ways to facilitate onboarding to Starknet. One of the big issues we have is the lack of content and the lack of documentation, which is perfectly normal for a project this age. But so we're trying to come up with different tutorials and different ideas to teach people how to leverage and how to use Starknet. So we came up with these tutorials you might have seen. So Cairo 101, which is a read-only tutorial. People just need to go there, read the code, and interact with the different tools of the Starknet ecosystem. We wrote two others, which are ERC20 and ERC721, basically explain to people how they can do on Starknet things that are relatively common and easy to do in Ethereum. And we released also this fourth one, which is the messaging bridge tutorial, which basically explains how to use the message bridge of Starknet to build cool cross-layer application. So a few things about these. First of all, I think they're okay resources. If people ask you, how do I get on Starknet, don't hesitate and point them to this repo. The second thing is that as Starknet evolves, these will need to evolve also. So sometimes we have time, sometimes we don't have that much time. And so if you see mistakes and errors in these tutorials, don't hesitate and submit PRs. There are some here. So if you see typos, don't hesitate and contribute. They are much welcome, and we're very happy to have them. And we will be releasing more of these in the future. And hopefully you, the community, will be able to do so also. We have seen various entities publish their own tutorials on how to build a front end, how to write smart contracts, how to get started with Starknet. And we're very, very grateful when we see these tutorials, and also very excited to see how people take different approaches to teaching Starknet. And it also, we quite often learn new things because we all use different tools and we use different features of different tools. So it's always really interesting to see how people build their own tutorial. And so for the second part of this community call, Luca, who is here with me, will take control. Luca will let you share your screen, and he will actually show you one of these tutorials that was done by a team called Only Dust, which made an interesting tutorial around Starknet. So Luca, if you want to show how to do this tutorial, and you in the audience, if you have questions or suggestions, please state them in the question in Discord or YouTube. We'll be watching. And if you know people who are curious about getting into Cairo, this tutorial is worth checking out.
Sure. Thanks, Henri. First, can you hear me on Discord?
Let's check. I don't think people can hear you on Discord.
All right. This will be. I mean, I'm not sure it's that important because it won't be that's relevant without the screen sharing. But I mean, if someone wants to hear the background, I'm not sure. Can you hear me now?
Yeah, now people can hear you.
Okay, great. So let's go. Okay, can you turn on the screen sharing, please? And first, I want to apologize for the background noise. They are building something in my
You can share your screen now.
Okay, great. And so let's share this. So the repo is called Starklings. You can find it on the Only Dust GitHub. Let me share the link. They had like this first implementation that they did for Starknet hackathon in Amsterdam, but they did an update that they're still working on, I think. And so we're gonna do like the old version because the new one is not available yet. So let's start. So this is like the old commits. I can share too if you want. Yeah, if you want to do it at home. Okay, so let's start. We're gonna start with the beginner one, and if we have time, we'll check the advanced one. So what they did is they did like a bunch of exercises, and they created tests, and the goal is that the unit tests all pass on the smart contract. So here you can run like the first one to see if it works. Here, 0, 0, workshop, and it will run the unit tests, and it should not work because obviously we didn't start the exercise. It's a bit slow. And we'll come back to that when it's finished. So what we have to do, it's written in the comments here. We have to create a storage variable named dust that maps an address to an amount. We're going to assume that the address, that with the amount is a felt. And for that, we're just going to create a storage variable. I have Cairo snippets that I wrote myself that is available on GitHub, which basically allows me to do that. And then I just have to fill in the variables. So it maps an address to an amount. So here we've got storage variable that maps the address to the amount. And now we can rerun the test. So here, yeah, it doesn't work because the storage variable doesn't exist. So just I'm gonna rerun that. And it should be okay. By the way, they're explaining like some interesting stuff for beginners. So how like a storage variables are defined, how an external function is defined too, and how views are defined. For those who are not familiar with Cairo, external functions are like the entry points that you can call. Views are like in Solidity, they're views. You can just view stuff. It shouldn't modify the current state of the smart contracts. And you can have like internal functions which would look like this, but you don't have the external decorator, so you can't call it outside of your smart contract. All right, so let's see. Okay, so the test passed. So let's go. We can continue. Let's go to the exercise 1. And so here we have to define 2 storage variables. The first one is star, and the star will map an address and a slot to a size. So this one will be like a tuple because you can't have nested mappings, so you would have to go with the tuple. So this variable will be called star. It will map an address, which is a felt, and a slot, which is a felt too, to a size, so it's felt also. And then we'll have the slots storage variable. So we're going to define it also, slots, and it maps an address to the next available slots. So we can keep tracks of the stars. So basically here, this variable is like the stars of each address. Like everyone can create a star, and it will have like a tuple as a key, because you can have multiple stars. So you can't store arrays. So you have to go with a mapping, but you can't have nested mappings. So you have to go with a tuple, which is like the address and the current index of your star. And here you have to keep tracks of each new slot of everyone. So you have to store like the next available slot for each address. And so here we defined our 2 storage variables. Here we're gonna create an event which will log the account, the slot, and the size of of the star, and then we'll just go like this. And so the event is a star is born. And so it takes an account, which is a field, it takes a slot, which is a field, and the size, which is also a field. Okay, so the event should be here, and this external functions allow people to create a star. So we're gonna write the body of the function. So we're gonna have to get the color address. So we're creating, we're getting the address, and so this is how it works in Cairo. You just call this function, which is imported here, which is basic, like you can have it when you install Cairo Lang. And then you have to put the address between parentheses because every function returns a tuple. But this one like is a single element tuple, so you have to unpack it. So we get the caller address. Then we want the amount of dust owned by the caller, and the amount of dust is stored in this variable. So we're gonna go with the amount of dust here. It's like dust.read and the address of the user, which is the caller here. And so we're gonna get the balance. Then we are going to check that the amount of dust is at least equal to dust amount. So we're going to assert LE, which is imported here as well. And it's going to enable us to assert that the first element is strictly less, no, is less or equal than the second one. So we want to check that the dust amount is less than the balance. So we're sure that he can pay for the star. Then we want to get the next available slot for the caller. And so I'm going to call it the current slot because it's the one that will be used to sort the star. And so we created like a slot variable earlier, which is here, and it takes like just an address and will return our slot. So we got our slot here, and then we're gonna update the dust amount owned by the caller. So the dust amount is still stored in the dust storage variable, and we're gonna write the new balance, which is like balance minus dust amount. Okay, so this is like the new balance. And then we want to register the newly created star. So we're going to register it in the star storage variable. And it takes like the slots of the new star and the address of the caller. So I'm going to put the caller address and the current slot and the size of the star, which is the dust amount. So here we have it. And then we have to increment the slot of the user. So slot.write cursor of the caller address, because we want to put it here. And we want to put the incremented current slot so you can actually perform operations in the function call, which is great. And you emit an event which will be a star is born that emits, and then the parameters, which are the account, the slot, and the size. So the account is caller, the slot is per slot, and the size is dust amount. So here we go, we have this, and so okay, so this is good. And we have to write views, and I'm going to use my snippet still here. And so view star, which will take
Luca, Saburo is asking what's being used for auto-formatting the code in VS Code.
It's the Cairo formatter, which is built in with the Cairo project, the Cairo Lang package. And then I just set the format on saves here. And then I put the path to the Cairo format. If you want to have your Cairo format path, you can just go with which Cairo format. And there you go, you have it. And you can just paste it here. I will send this in Discord. Yeah.
What can you explain a bit? What's this settings.json? Is it something you have? It's your VS Code settings?
Yeah, it's the VS Code settings.json that you can reach some way. It shouldn't be really hard. And then you can set whatever you want. These are my settings. Feel free to have your own. If you don't want to put the format and save, you can also use like the regular Cairo format. You can Cairo format your contracts here. And whatever we want. All right, you can format this like this. It will like print out the formatted contract in your terminal, or you can like do it inside your file, adding the -e flag, and it will modify your file and format it for you. So let's come back to this. So the view, we want to view a star, and a star needs an address and a slot. So we're gonna get them as parameters. Address, which is a felt, and slot, which is a felt. It's not mandatory to type every variable. I just like to do so. It's not mandatory. So we're gonna get the star here. Star.read, and then the address and the slots here. And for the slots, view slots, it takes an address and it returns. Yeah, it returns. Okay. Actually, I made a mistake here. It returns a field. And here, so, the two variables here don't have to match. You can do whatever you want. I like to match them, but my personal preference. And so the res will be the slot, the next available slot of the user. So slot read and the address here. All right, so I think we're good for this one. And we're gonna run the test. By the way, I did this because here, like it's the name that they wanted to implement. So you have to go with the same name as they did in the unit test file. And here, all right, we'll see after if it went through. Second exercise, we want to store a star size. We want to give a name to a star, so let's create a struct. So struct, the name will be star, the first member would be the name, which is a felt, second member is a size, which is a felt. Both, yeah. So this is the link to the documentation of struct. And here update the star storage to store star instead of felt. So star instance enters the slots and returns a star. right. And update the star. Okay, so it's okay. And here, update the light star somehow so it may take a star. Okay, the light star, which we're going to copy paste from the previous exercise. Up here. This is misleading. This is misleading. Instead of dust amount, we're going to take a star, which we're going to call new star, so there's no conflict with the storage variable star. And it's a star. And then we're going to do a lazy trick, which is define dust amount equals to new star size. Here we've got the address, we've got the balance. We check that the balance is all right. And then we write, okay, so this is still okay. And here we're gonna write the new star, not the dust amount, increment the slots. And should we update the, so it takes star, so this will go like this. All right. This should work. We're going to create the views after we see if the previous tests worked. And they didn't because I didn't put the right variable name, which is color. Here starts. Here it's color, not address, and it should work. All right, we're going to create the views. The section we want to create. Zero, and I'm going to do star, which takes images, and a slot, and returns a star. And so we're going to go the same. Equals star create address slots and this expect this dot right here because we're gonna write on the color address.
Hey Lucas, there's a question. Mixabox is asking, did you create a custom VS Code shortcuts to autocomplete the storage var implementation?
Yeah, I created VS Code snippets here, which are here. These are my snippets, but they're available on the Starknet edu GitHub. Not sure if it's the latest version, but there is at least something. So you can go here, and the Cairo snippets are here, and they're here, and you can just copy paste them if you like. I'm gonna put the link on Discord because I'm not sure I can put them on YouTube. Yeah, you can just add them in your own VS Code snippet file. But this will save you like a lot of time. There are for revoked references too. Like it will just go like this, and you just have the 3 implicit arguments, which saves a lot of time. Here we got everything we need to start. All right. So the test passed for the previous exercise. Now let's go with this one. And we're gonna go to the next exercise. Oh, so we're gonna get recursive now. So we're gonna create a batch of stars, which is an array of stars. And so what this does is it writes a star into the storage. So we'll just have to call this function on each element. So when the length of the array is 0, we want to return, because it means that we created every star. Okay, okay, and then we gotta put an end here. And then what we want to do is to create a star in the order, the start index. All right, so if we want to create it in the order, we want to insert star. What it does, it takes an address, which is here, and it takes the new star. So this is the array. This is like a pointer to each star that we will increment. You can view like the memory as an array, and this is like the index in the array which it points to. And so to access the value, you can just put the pointer into brackets, to square brackets. And so the new star, because here it wants a value, it doesn't want a pointer. And after we've done that, we're gonna increment, we're gonna decrement the array length because we got one, and we're gonna increment the pointer. So if we want to do that, we have to go fetch with star, which takes an address, takes array length, but we decrement it because we already put one, and then we have to go with pointer array. I think it's something like this, and you go. All right, this should work also. Previous one didn't because it has the same problem. This takes the address, which is color, and this doesn't take address to color. This goes, and here we're gonna test how 30 is size. Which is this one from workshop. And we hope for the best. Okay, so the first one passed. Now let's see the second. All right, we're going to go for exercise. This one wants to keep track of ranks. Okay, so this one is for revoked references, which you will see a lot if you go with if-else statements. So this one passed, so it's okay, and this one we're gonna see soon. And so this one keeps track of rank. All right, 1 for Starklings, 0, 3 for okay. So here we have to increment the rank of the color. Okay, so we're gonna check. Okay, so this one. So if the new user slot is equal to 1, we have something. So if current slots plus 1, because it's the new one, equals to 1, all right, we're gonna update the rank. That's right. So we need the address and write the rank. So it will be 1 because it's the first rank. Else, if current slot plus 1 equals 10, then we increment the ranks. So it's 2. Else, if the current slots plus 1 equals to 100, we're going to write if rank 3. And so here we can end, here we can end, and here we can end. And now this won't work because there will be revoked references. All right, so the test of this one worked. So let's try to compile this one. This is like the fourth one, and this will have revoked references. Okay, so this is called pointer has been revoked. So what's happening here is that there is one instruction here, and there are lots of instruction here. So so Cairo loses track of the implicit arguments, and what you can do to solve that is to create 10 vars, which will place the syscall arguments, the implicit arguments at the same place, so the compiler will know how to retrieve them. So what you do is that, and I'm not sure where to put them, but probably somewhere around here. And this. Does not work, and we're probably gonna get them here. Nope, let's add some more. This is like a high-level debugging technique. You just put them everywhere until it works, and then you delete them until it doesn't work.
Is that best practice?
Yeah, yeah.
I mean, it works, but
I mean, if you have like nested if else's like that, like it's probably easier to go like this. Let's put some more. Maybe here. Probably not the optimized way. I should probably have done.
I think you need to put an else to your second if.
This one?
Yeah, you need to put an else and put your temp bars in them.
Probably. Oh. With the cleaner, yeah, so it works.
It works. Cool.
And so this should also work. But the point is, it's probably not the most optimized way. You should probably go with if blah blah blah, else blah blah blah, and another if else. Not nest them like this because it's like unreadable. And yeah, we're going to assume that it works. I don't know if anyone has questions.
There were some questions. I relayed them to you. I think we can wrap it up. So can you share again, please, the URL of the repo, and if you have suggestions for people to do it, or if you want to say some concluding word.
I'm gonna just share it again. For people that are starting with Cairo, go with obviously the beginner one. It has like a great path of introduction to Cairo. You start with basic stuff and you go to more complicated stuff. So this is a great tool. Obviously, the Cairo 101 on Starknet edu is probably the best to really start off. But yeah, this one is cool too. Don't be afraid of revoked references. We don't really care if you put like 10 vars everywhere, like I did. Um, just have working code and improve it after. That's what I would say and what I would advise people to do. So that's it.
Wonderful. Thank you, Luca. Okay, so in order to, before we conclude the call, just wanted to mention two questions that were asked. One of them was, thank you for the update. Is there a release date for 0.8.2 and 0.9? So 0.8.2 went to testnet today. It will go to mainnet. I think we usually push them to mainnet 2 weeks later. 0.9 is planned for mid to end of May for testnet. The second question was, will improvements related to parallel execution in the sequencer be released in 0.9? I asked the question to the team in charge of these improvements, and they said that yes, these improvements are still in store to be shipped in 0.9, but we don't have a lot of insights on them yet. We would like to get some kind of metrics to make sure that they will make things better. So if we do, we'll ship them and we'll see. But basically, this is ready. We just need to make more measurements to make sure that it doesn't break everything. And that's it for the roadmap update. I also want to end this call with a reminder of upcoming events around StarkNet. So the first thing is next week, there is an event in Miami. There's going to be a hackathon where various teams are going to be able to build on various ecosystems, amongst which we'll have StarkNet. So if you're in Miami, do check this out. If you're in the US, you can still register, so go check it out and go build cool stuff on StarkNet. We might organize an online hackathon in June, which you'll be able to join from everywhere. It has not been fully decided yet, but probably we'll do it. If you have thoughts on online hackathons, do you like them? Do you not like them? How can we make them better or more engaging? Do let us know. We want to make them better. After that, in July, there will be an on-site hackathon in Paris around HCC. Hopefully, you'll be able to compete online also, but for sure, if you're in Paris around HCC, there will be a StarkNet hackathon, so you can start planning for that. It's going to be a lot of fun. And finally, we may have another on-site hackathon in Europe, in London. We are not. This is not sure yet, but we're sharing alpha things with you, so not sure, but probably will happen. If you're interested in organizing hackathons or meetups, do reach out. We need more people to foster the community and help our community grow. So if you have an interest in organizing meetups and having fun with fellow StarkNet enthusiasts and talk about cool projects in your area, reach out and we'll see how we can help. Send you some swag, support you any way we can. And that's about it for me. I'm going to check if there are other questions. There doesn't seem like there is. So let's wrap it up. Once again, thank you all for joining. And I hope you all have a great week. Goodbye.
Goodbye.